Hi everyone, today we will be presenting on how building information modeling can be used in estimating and cost control. This presentation will cover what BIM is, how BIM can be used in estimating and cost control, the state of the art in the industry, application and academic research, analysis of BIM tools, and finally we will be going over some case studies. A building information model is a collection of geometric shapes. However, unlike a typical CAD model, BIM has the capability to have 4D, 5D, and even n number of dimensions. These dimensions range anywhere between time, cost, and even material property of the object. With the ability to store this much information in a model, BIM can be a very useful tool for estimating and cost control, and can be even useful throughout the whole project management process. With the use of BIM tools, the process of developing takeoff quantities becomes very simple. BIM tools are easily able to count objects and tabulate takeoff quantities into schedules like the one shown here. Bidders can then use these to estimate costs of constructing a project. With the bids that are received, the owner knows that each bidder has carried for the correct items and can easily compare the bids and choose the best one. Aside from estimating, BIM is a great tool for managing costs. For example, if there are changes that need to be made, BIM can detect and warn owners of potential collisions that may arise. When collisions are detected early, designers can use building models to quickly prototype many different solutions, and with the use of pricing data, can choose the best solution. BIM is a great tool that can let you spot problems early on and develop cost-effective solutions. Ultimately, this leads to better project coordination and cost mitigation.
Cost estimation in AEC industry was traditionally done by manual QTO calculation. This process can be very time-consuming, and manual calculation is prone to human errors. With the recent surge of BIM technology, we were able to combine the calculation process with the 3D model of the product, and significantly decrease both the effort and the errors. However, the early BIM implementation usually has one type of tool developed for one particular aspect of construction management. Different stakeholders can be using different BIM tools that cannot easily communicate with each other, and this limits the full potential of BIM in cost estimation. But BIM technology is the general trend in AEC industry. The future of cost estimation relies on a more proper utilization of BIM models. That is, future BIM implementation will be more systematic. A single BIM model will contain information about all cost components related to the project, which makes it usable for all parties rather than one tool for one stakeholder. Here is a schematic for a BIM-based integrated framework. The construction-oriented 3D product model is the foundation of such framework. Information about quantity takeoff can be pulled from this model, as many designers and engineers have already been doing. The construction process information database is what makes this framework outstanding. It includes all kinds of information on the construction operation level, from element purchasing price to construction labor cost. The 3D model and the database combined will be able to generate cost information by matching elements in the model to related entries in the database. Communication between different parties will be much easier as well. With this integrated framework in place, contractors and subcontractors can update their product or service information in the database, while designers and owners can continue working on model without going back and forth on changing attributes. Since the 3D product model part is a rather well-developed topic in the industry, the future trend of cost estimation using BIM models is an inclusive database that contains the knowledge about everything construction related. Material price, transportation cost, on-site labor cost, not to mention that price varies between different contractors and installation methods. The more inclusive the database, the more accurate the cost estimation. Moreover, owners and designers can use this kind of BIM model to easily simulate for costs under different circumstances, such as changing combinations of contractors. Therefore, they can obtain a more accurate budget from the model as early as in design phase, and potentially use the result for decision making.
Next, I'm going to talk about the three available BIM tools: Revit, ArchiCAD, and Open Building Designer. Revit is a 4D BIM tool developed by AutoCAD for structural and mechanical, electrical and plumbing engineering, construction and architecture design. It is great for creating unified models that all disciplines can use throughout the project. One downside of Revit is that it can only be operated on the Windows system. Revit has 5 notable features. The first one is that it is a multidisciplinary tool. Revit is an economical and powerful solution for a team composed of architects, engineers, and construction professionals. The platform has tools expressively crafted to meet the needs of everyone involved in building a structure. Revit is an immersive model. It has a one-click 3D modeling tool that transforms design into effective visualizations. It also provides detailed visualization that any member in the team can view the finest details of the model. Moreover, when you connect the platform with other capable Autodesk softwares, you can create more informative models that can assist the team in other processes. Revit can also document images. With these features, you can provide other team members with every piece of information they need to build the specification. Revit is an interoperable platform. Revit works well with files producing using other software such as IFC, DWG, and DGN files. With these compatibilities, different platforms can use the same file extension. ArcCAD is a 3D BIM tool for urban planners, architects, and designers to enhance design workflow process. It is one of the first BIM implementation. It is tailored to handle the demands of modern architecture, 2D, 3D design, and BIM functions, right from the planning to project implementation to facility management. The variety of visualization and BIM function of ArcCAD made it useful for any construction architecture firm. This tool can be used with both Mac and Windows systems. ArcCAD has two notable features. Its algorithmic design helps to avoid gaps between early-stage design and BIM. It facilitates real-time editing and communication, thereby making model checking and coordination more efficient. Its open workflow enables participation of project members regardless of the tools they use. The platform provides a clean workspace where only widely used functions are displayed. ArcCAD also allows you to create new properties and values based on the parameter of the element. Open Building Designer is a multidisciplinary building design software system for design, analyze, construct, and manage infrastructures of any scales and type. It is a BIM tool used by architects, electrical, mechanical, and structural engineers. This tool can be used with both Mac and Windows systems. Open Building Designer has two notable features. It provides effective collaboration across multidisciplinary teams in a common design environment and streamlined workflow. It allows users to accurately and conveniently analyze building system performance. Open Building Designer allows building documentation and reports to be directly generated from a user's intelligent building model.
What's the foundation of BIM estimating? In order to streamline the estimating frameworks utilized in the construction industry in China, ZEL introduced an information model to integrate the IFC standard into tendering estimates. The model introduced linked IFC entities with estimating requirements that pertain to resource prices, the timing of construction, and regulatory requirements. Now, what does the future of 5D BIM estimating look like? It's the intelligent acquisition of construction information by developing machine learning models that enrich BIM models with the necessary information to develop more accurate estimates. Training those developed models using the actual information in order to optimize and continuously improve the outputs. Controlling costs is one of the most important determinants for project success, and 5D BIM offers numerous tools and mechanisms that streamline the process. Starting with procurement purchasing. BIM tools now allow for the direct purchasing of products and specifications and schedules from the platform. For earned value management, by tracking completed elements and contractor pricing to determine the cost impacting elements and projected final budgets. Cash flow forecasts. 5D BIM tools allow for the modeling of complex contractual relations that can simulate accurate cash flows early on in the project. They're updated as changes are made. And finally, change order management. The integration of the model with costing information allows designers to simulate multiple options and their impact on the overall project, reducing the number of waterfall changes.
In the first example, 5D BIM technology was applied in electric power industry in China. The substation shown on the slides is located in the northern China. The building consists of one main structure and one ancillary building. In the design stage, parametric modeling and family libraries are applied. After modeling, the team used Excel and pricing software to transfer the data and estimate the cost. The Revit family library is considered as a comprehensive solution for BIM technology, with features such as structural and architectural design. Figure on the slides shows the examples of components and the corresponding families. Besides, Revit extensions are applied to design and analyze the structural components of the building. BIM technology makes the quantity takeoff process easier because all building components are included in the Revit family library. As the figure on the slides shows, different types of doors are listed. And besides, reinforcement concrete and the other facilities are summarized as well. The project team also manually calculated the quantity of building components. Compared to the manually calculated results, there are errors on the Revit results. For example, the quantities of walls is slightly lower than the correct value because the calculation did not consider the volume of columns and beams. Revit cannot estimate project cost, so after quantity takeoff, there are several methods for data transfer, as shown on the slides. And at last, the second way is selected for transferring the data, because this method has the highest feasibility in this case. The team did not need to change the data interface of the pricing software. Data entry is fast and easy. The drawback is the team needs to spend time to develop a plugin program in the Excel. The figure on the slides shows the data transferring and the cost calculating process. And finally, the total cost of the project is about 4.3 million Canadian dollars. There are several highlights in this case study. Notably, BIM technology will help in reducing rework and helps the owner save 0.25 million Canadian dollars. It also helps the team complete the projects ahead of schedule and improve the overall labor efficiency.
The project under consideration is a high-rise residential building in Fujian, China. It consists of a basement and frame shear walls. It was designed to resist a 7-level earthquake. Due to the grand scale of this project and its complicated HVAC and water supply pipelines, it is necessary that the project is well planned and the construction well coordinated. As such, this project lends itself well to the use of BIM and value engineering. All disciplines on this project use Revit for their BIM modeling. The BIM models were then integrated for clash detection using Naviswork. Then the BIM data in the model was then used to generate a BOQ. An integrated BIM process was used for cost estimating and control by carrying out value engineering, clash detection, site management, and planning. On completion of design by the various disciplines, the BIM models were integrated and checked for clashes using Naviswork. 1,821 clashes were found and rectified. This led to a savings of 80 days of project time and an equivalent of $87,000 in rework. Also, the construction site layout was planned in advance by using BIM. This was done to reduce costs by reducing material transportation time, optimizing handling of large machinery that would ordinarily increase costs, and optimize the project schedule. Using the data gotten from BIM, the project team were able to use value engineering to build a hierarchical cost of building components and the composition of the project costs. This enabled them to identify the chief causes of the high cost of the project and attend to them appropriately. Cost control was done by exporting a GFC file from the BIM model in Revit to a GCL software. A BOQ was then generated and imported to the GBQ software to generate the total cost. The value coefficient of this is then analyzed and calculated. A value coefficient of less than 1 indicates that further analysis is needed to improve cost control. From the case study, it is seen that BIM is an efficient tool in cost control and estimating, as it enables the validation of ideas to enhance design and construction via value engineering. It also minimizes and possibly eliminates rework, leads to a reduction in project time and costs,